Okay, ladies and gentlemen, we're going to just go ahead and start doing some examples on proving two triangles congruent. And then towards the end of these notes, we're going to introduce you to our new topic, scale factor. So before we get going, it's very important that when we prove triangles congruent, that you kind of look back at the previous video or your previous notes. I tried to include it down here. I copied and pasted what I'm really talking about. These are the steps to proving triangles congruent. So if you have those written down, it might be a little bit easier to see in your notebook. So saying that, let's get started with example A. So in example A, we know for a fact, based on this statement, that this triangle is congruent to this triangle. Because of this statement, we can take any corresponding part and put it equal to any corresponding part in the other triangle. Okay? The reason for this is CPC-TC. Okay, we talked about that in the last notes. So for example, we know angle A is 22. And because angle A is 22 degrees, and these two triangles are congruent, we know angle A matches with angle D based on this statement up here. So I know that angle A and D are congruent. Because of that, I can now put angle A equal to angle D. And that's the work I'm going to do. We can now use this equation to solve for y. So I'm going to add 3 to both sides. 25 equals 5y. Divide by 5. And we get y equal to 5. So we have solved for y. All right. On the same token, if we look at the sides, since again these two triangles are congruent, I can put sides congruent as long as the sides match. So I can take side AC, if you look at the statement, A and C match with D and F. So here's side DF. I can put those sides together now and put them equal to each other. 9 equals 3x. To solve for x, we now divide by 3. And we get x equal to 3. So that's how you do example A. So let's go ahead and fill in the information here at the bottom. X we now know is equal to 3 because side AC corresponds to side. So again, corresponds means matching. So AC corresponds to DF. In congruent triangles, corresponding sides are congruent. And this is that CPC-TC that we talked about before. All right, we also found out that y is equal to 5 because angle D corresponds to angle A. And again, in congruent triangles, corresponding angles are congruent. Okay, so once you have congruent triangles, you can put their parts equal to each other. All right, let's move on to example B, and we're going to do a proof. All right. So what I like to do first, and this is in your steps, okay? So let's look at the steps. I want to label the information that is given to you. So what that means is I want to add it to my drawing. So if it's not labeled, we're going to label it. So angle A is congruent to angle D. If you notice, this is already labeled, but I'm just going to put it in color now. So we have an angle congruent, and then we also have AC is congruent to DC. So AC is congruent to DC. And again, that is marked with these little dashes. Okay? Our goal is to prove triangle ABC is congruent to triangle CDE. So, How do we do that? Let's do our statement. So the first statement I'm going to do is my givens. I put the reasons down to remind you. So I'm simply going to put angle A is congruent to angle D. And then my other given is AC is congruent to DC. Okay? So if you notice in my drawing, what I really have found congruent is I have an angle congruent and I have a side congruent. Okay? So keep that in the back of your head here. Now we're going to go to step 2. I'm now going to look at the picture, the drawing, and see if I can figure out any of these based on the drawing. So let's look at the drawing. And what you should notice in the drawing is we do have vertical angles here. So I'm going to label those as congruent. So this angle here, I can say is congruent to there. So I'm going to label that as angle ACB is congruent to angle DCE. And again, I'm using 3 letters because I want to make sure you know what angle I'm talking about. And the reason for this is because I mentioned before it's vertical angles. So this is information I had to get from the drawing. Okay, this was not given to me. All right, so now if you look, I have a second angle congruent. So now let's see if that's enough information. If you look over here of what I listed, I have an angle congruent, a side congruent, and an angle. This might be enough for a shortcut. So step 3 says, once you do that, we want to decide if we have a shortcut. And the shortcuts we're talking about is the side, 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 side angle, side, all that good stuff. Okay, so let's look at our drawing here. So I like to start at just one of these corners or sides. So I'm looking at angle, and I'm going to go this way. So I have an angle, side, angle. All right, they are marked, which means they are already congruent. I don't have to check it with the other triangle. They're marked already. So angle, side, angle. Because those are congruent, I can now say my proof. I have enough information to say triangle ABC is congruent to triangle DEC. And the reason, the shortcut I'm using is, again, angle, side, angle. Always check your drawing to see, without skipping, remember you only can skip one part. We didn't skip any in this case. And we have our congruent statement. Okay, go ahead and I want you to try example C here. All you're going to do is fill in this information. I will remind you, when you see congruent, we have to put another part here. You can't put a number. When you see equals, it's equal to a number. All right? So fill this in. And on Google Classroom, I want you to give me the measure of MT on the comments section of Google Classroom. Give me the measure of MT. All right, let's do example D. Let's do this proof. Again, I'm going to mark what was given. So we're given JK is congruent to NM. So let's color code this thing. JK and NM are congruent. And again, I'm going to mark it with the dash because that's the proper way to do it. And then we also have angle J is congruent to angle N. So angle J is congruent to angle N. All right? So if you look at our statements and reasons, I kind of put that already. So then I can try. I give you a statement. I want to see if you can give me a reason. So if you remember our steps, once we mark the givens, now it's time to look at the drawing can I say something about the drawing, some information about the drawing that I can come up with? And what you should notice is we have vertical angles again. So if you look at my statement, it says K, L, J, which is this angle here, is congruent to MLN, which is this angle here. Okay, and the reason for that, we know those are vertical angles. Okay, so since we can't get anything else out of it, I'm just going to list what we have. So the given statement, again, it gave me a side congruent, it also gave me an angle congruent, and this second statement here gave me another angle congruent. So again, we got 3 parts congruent. We just got to see if it gives us one of our shortcuts. So again, I like to start on this triangle, and I'm going to go towards my next congruent part. So I'm starting at a side congruent. This way I have an angle, so we haven't skipped any part. So side, angle, we skip angle. So side, angle, angle. Again, if you say that out loud, side, angle, angle, it is actually one of our shortcuts. So we're saying side, angle, angle, but the shortcut really is angle, angle, side. And all the difference is we just switch it around. We start at this angle, so angle, skip, we're allowed to skip one part, angle, side. So this is congruent by angle, angle, side. Okay, so the last example here is we're going to compare corresponding sides, again matching sides of these congruent triangles. We already know they're congruent, and we're going to try to figure out what ratio do the lengths produce. Again, ratio is just a fancy word for fraction. So the best way to explain this is I'm going to match sides from this triangle to the other, just the sides, not the angles, and I'm going to put them in fraction form. Okay? So let's take a peek. So I like to start with the shortest sides. I want to match by shortest sides. So if you look, HJ is my shortest side over here, and that is 1. 1 meter, I'm just going to put the number. Okay? HJ matches with the other short side over here, which is LM. That is also 1. If we reduce that, that equals 1. So their ratio is 1. Okay? Now we're going to go ahead and do the middle side. So we're going to start with the side we started over here. So I took a side from this triangle, so that means I got to start over here for my fraction. This side has to be on top. So the middle side is going to be HG. It's 1.7. So HG over, and who's the middle side over here? That's going to be LK. And if we put their numbers associated with HG, HG is 1.7. LK is also 1.7. If we do the math there, that also gives me 1. Now we're going to do the last set of corresponding sides. The longest side on this triangle first is, we'll go JG. And the longest side over here is going to be MK. And if you plug in those measurements, it's 2 over 2, which is also 1. Okay, what I want you to notice now is what we've just done with these fractions. When we match sides and create a fraction, this fraction is actually called a scale factor. Okay, so these are all the scale factors, and you should notice the scale factors, or the number we get after we create the fraction, right now is 1. So these all have a fraction of 1. Because of that, this is called a scale factor, and it's very important that you understand this idea. When these two figures are congruent, the scale factor should always and will always be 1. So in other words, when I match sides and turn them into fractions like we did here, no matter what the side measures are, if you match them correctly and these triangles are congruent, your scale factor should always equal 1. Okay? So this is kind of where we're headed here, this extension, just something to wonder about. What would a scale factor or 2 to 1 mean? Okay? Would the triangles still be congruent? Okay, just something to ponder here. And again, this is kind of where we're headed. We are headed in this direction.